Welcome back to Algos Made Simple. Have one that's a little bit more on the difficult side today, but I think after you see the simplistic solution and we talk through it a little bit and you do this problem a couple times, that it'll be one that you can definitely get to the solution if you encounter it in an interview or whatever setting. It's just about understanding conceptually and knowing your game plan outline, not necessarily being able to just regurgitate the code. You just need to understand, okay, when I see threesome or something like it, here's my plan of attack. So with that being said, let's dive in here. It's Leetcode 15 threesome. Given an integer array nums, return all the triplets, nums and index I, nums and index j, nums and index k, such that I does not equal j, I does not equal k, and j does not equal k. And nums index I plus nums index j plus nums index k equals 0. Notice that the solution set must not contain duplicate triplets. So I'd let the interviewer know, okay, I understand I'm getting an array of numbers, and I want to return every set of 3 numbers that sums to 0. I don't want to return duplicate sets, and I can't utilize the same indexed number twice. So if I have an index 0 and it's the number 1, I want to use that 1 again, I can't say, okay, I'm going to use index 0 again. It's not what you can do. That has to be 3 separate numbers. I can't equal k, j can't equal, that's the whole thing there. So with that being said, I understand it conceptually. I look here at the example. You got -1, 0, 1, 2, -1, -4. Your output is obviously -1, -1, and 2, and then -1, 0, and 1. So if you had this in front of you, an array of numbers, and had to find the groupings of 3 equals 0, could easily do it. So we're not asking anything big as far as complexity conceptually, but how can we get the computer to do it? Well, that's when we bring out our game plan to try to simplify things. And the first thing you realize is, okay, I'm going to return a list of lists. So let's go ahead and think about a resolution list and set an equal to that. So that'll be just the start of our problem. We'll have that. So that gets us already kind of going in the right direction. All right, I know that it's going to be, the stuff I'm appending to that list will be a plus b plus c equals 0 type of situation. So how can I get this a plus b plus c? How can I get these numbers? Well, if you think back to twosome, the suboptimal way of doing it is the double nested for loops. So suboptimally, which I don't know if that's a word, suboptimal, we could do triple nested for loops, but one, that's going to be O of cube, which is horrible, and two, you're going to have to really put some stuff, some different parameters and stuff in there to make, or different constraints, to make sure that you don't return those duplicate triplets, because you're really going to have to make sure, okay, have I used this yet? Have I used this yet? So it's going to be a lot of code. It's going to be very, it's not going to be simple like we want it to be. So I would go ahead and just say that's not going to happen here. That's not what we want to use. So delete that. So what can we use? Well, okay, the optimal solution of twosome has a hash map. And, you know, all we would do is just go through and index the numbers and pull the numbers out, and then just see if that number had the target minus the number. If that difference is in the hash map, we return it. But we're dealing with 3 numbers, so how are we going to get that first number? The best thing you could do is do a for loop for that first number. So we're always going to pull the first number and start with that. So that's going to be our starting number. And we're going to need something in place to check if we've used it before. So you could have something like if that number equals the number at index I minus 1 or something like that. So if we already used it, we'll continue. But that's where you're going to be pulling your original number from. Okay, so then we could, after we pull that original number and say, okay, we've got that plus whatever else we pull out here is going to be our, so we'd have that. So you'd have your number from the first for loop, so let's call it A, plus you would be pulling your number in this next little section or whatever, and then you'd just be searching for what number would make that equal 0, and if that's in your hash map or not. So that's a way you could do it. Again, it's really difficult to kind of make sure you don't get duplicates that way. So what is a different way we could do? Okay, so if we're pulling that first number out, if we had a sorted list, if you've ever done twosome 2 before, if you have a sorted list, so if we take that nums.sort, then all of a sudden we know that what we're dealing with here, and we know what order it's kind of coming in, and we could use pointers for the second section of this, and if our sum is too high, then we could move that right pointer in. If our sum is too low, we could move that left pointer up, and then we could just wait until we hit 0, and anytime we hit 0, we just reset it or bump the left up and kind of go from there. That could be a play. So again, this one's a little bit more complicated, so it'll make more sense when I cut it up. It's kind of tough to talk through in your game plan here, but basically the main thing we want to take away is, okay, we're returning it as a list. We got that. It's going to be a plus b plus c equals 0. We're going to pull the first number from a regular old for loop, and then we're going to sort the numbers at the very beginning too, the array. So let's put that towards the front here. And then we're going to, after we have that regular for loop, we're going to set pointers for the rest of the problem. So what does something like that look like? Okay, so let's say 3 sum, and we got nums. Okay, so we know we want our res set, our res array, and we know we wanted to sort the nums. So we got nums.sort. So now we're dealing with this right here where it's -1, 0, 1. So we know what order these things are coming out of. So -4 for the start. But anyway, so we got nums.sort, and then we're going to go to our first for loop here to pull the first number. So pull first number, and we've got, move that over a little bit more. We've got for I comma a, so your index and your actual value, in enumerate nums. And you've seen us do that in 2sum if you've watched that 2sum video before. And you could, if you're kind of scared off by enumerate, or maybe you don't have it in the library or whatever, you could just keep track of your index and just do the I plus 1, start your I at 0, and kind of go from there and keep track of your index that way. But anyway, what we're going to say here is, if I is greater than 0, so we've gone through our first number, and a equals nums at index I minus 1, in that case we want to continue and just go to the next number. And the reason for that is we're trying to avoid duplicates. So if I just got done doing -1 at the start, I don't want to do -1 again at the start, because I'm going to end up falling for the similar or the same exact subset or whatever, and I'm going to be returning that. So this right here we can put out here is avoid first num duplicates. Alright, so we're tracking there. The next thing we're going to do, so if we're able to utilize that, we've got our A, so we want to come in here still inside the for loop, and we want to set our left and right pointers like we talked about doing. So I have left and right, and your left is going to be I plus 1, so wherever you're at right now in the I, you want the left to be plus it, because we have it sorted. And then we'll say, and you don't want to utilize the same one, so then we'll do len nums minus 1, and what we'll do from there is while left is less than right, we can pull out a value called total sum and set it equal to a, so that's our a from pulling up here, that's our first number. Our second number is going to be the nums at left plus the nums at right, and here's what we're going to do after that. So we've got that, we've got a sum to check, that's great, we've got 3 numbers here. We're going to say if total sum is greater than 0, so it's too high, then we know we just need to simply move that right in 1, right minus equals 1. And then else if total sum is less than 0, so we're negative, then we know that left needs to come up and we need to get to a higher number. And again, this is sorted, that's what gives us the ability to do this. Else, if it equals 0, then we're simply saying res.append, and we're appending a nums at left, nums at right. And that's going to be one of our answers there. So then all we have to do from then, because our right is going to get, our pointer is going to get updated up here as long as we bump this left up one. Our pointer is going to get updated right in here kind of thing. So what we'll do is left plus equals 1. So that'll update our left pointer, and then if we need to update these pointers up here, it'll update it. We just need to not have the same subset come down and append it again. So that's going to update our left. So when we come up here, we're a little bit closer to this left being greater than the right, and we're utilizing a new left. All right, and then what we'll do from there to make it even cleaner cut and even better, we'll do a while loop right here and say while nums at left, because we want to check again. This is another part of avoiding the duplicates. Equals nums at left minus 1. So what we just had for left, if it's the same number of what we just had, then we don't want to use it, and we want to make sure that left is less than right. So while that's happening, we want to, so if the number is the same as what we had last time and it's still less than right, we want to have left plus equals 1. So we want to get even more to the left here. Let me get all this on one screen here. All right, so left plus equals 1, and then all we're going to do after that, once we're through this for loop up top, the very first for loop, we're going to simply return the resolution list. So a little bit of complex code, but if you just remember, okay, I got to pull my first number. I've got to avoid first number duplicates, and that's how I'm going to do it, is making sure it's not the same as the last one. And that's, again, leads back to why nums.sort is so vital here, why we have to sort these numbers. And then you want to avoid any future dupes, which is what you're doing down here. Hashtag avoid secondary dupes. By doing this while nums left equals nums left minus 1, then you want to bump that left up as long as it doesn't get where it's more than the right, because then you're through it. So that's all there is to this one. It's, again, a little bit complex, but once you do it a couple times and really get the feel for it and realize, okay, I'm returning a list, I need to pull this first number, avoid first number duplicates, avoid secondary duplicates, and I can use pointers to kind of update here as opposed to a hash map, which, again, if you get really stuck, you can pull this first number here and then just do it like we did twosome with a hash map, but you are going to have to, I guess, sort the incoming list like this or whatever and make sure that you don't already have them in the resolution set. So that would be kind of the holdback on that. But this right here is O of n squared. We've got O log n on this nums.sort, or O in log n, but we have these nested loops right here. So that gives you the O n squared. So you go with the greater time complexity O of n squared. So thanks, guys. I know this one was a little bit more complex, but hopefully did a decent job of explaining it. If you got something that's an easier way to do this problem, please leave in the comments. If you have an easier way to describe this solution, because I know I struggle with this one a little bit, please let me know, and I'd be glad to utilize it myself, or anybody else that looks at it it may help them out. So again, thanks, guys, and we'll be back in the next one.